5, perpendicular lines and angle bisectors. So this diagram is familiar to you guys. These circles are the same size because they have the same radius, AB. Okay? EA has to be the same as EB. Why? Because if you were going to draw these line segments, they would also be the same as a radius, right? BE is a radius of circle B. AE is a radius of circle A. There you go. That's number 1. This one down here, we're looking at these, right? AF is also a radius. BF is also a radius, right? And if these two circles have the same radius, then those two radiuses or radii should be the same length. There you go. That's the first two. Draw line EF. Here we go. We're going to just draw this line. Right? Now this tool only gives us, notice that I use this to pull up this menu. This is the geometry set of tools. Put this away. All right, and we can move this down here. All right, so just making sure that now this is not a line technically, it's a line segment, but it does go through point E and point F. And we know, right, we've talked about this, we create perpendicular bisectors this way. It splits AB perfectly in half, and it meets at a right angle, right? This is a right angle here. E, if we call this, what's the letter that's missing? I don't know. AXE or BXE or FXB or FXA, those would all be right angles, okay, because these two are perpendicular. All right, so EF would be the perpendicular bisector of segment AB. All right, here's a line, right, here's the line L. It has point C. We're going to use the straight edge and compass tools to construct a line that's perpendicular to this line, but it goes through C. Okay, now this is a challenging question. We're going to use just these tools here, and we're going to create a line that goes straight through C, definitely exactly through C, and it is perpendicular to line L. Okay, now this doesn't mean to just say, okay, we're going to do this, and we're going to go, oh, this looks like it's about parallel, perpendicular, perpendicular. We're not doing this. This is wrong, because this is just guesswork, okay? We're actually going to use what we know here to create a perpendicular line. Notice here is a perpendicular intersection right here, right? And ideally we want point C to be right there, right? Ideally we would want, let's see if I can find this, yeah. Ideally this would be point C right in the middle there, right? Oops. Let me move this around. Graphics view. Select objects, protractor, graspable math. No. Okay, well. All right, there we go. All right, so we know that this is a perpendicular line. We want C, ideally C would be this intersection point right there, okay? But on this diagram, right? We want that vertical line going right through there. So the key is, you guys look at AB. If it's a perpendicular bisector, it means that it's perpendicular, but it also means it's a bisector, meaning that this piece here from A to C, this point right here, that line segment right there, and this line segment right here, they have to be the same length. Okay, if we wanted to hit C, the two pieces on either side have to be the same length. All right, here we go. Let's see if we can do this. So how can we get two pieces on either side of C that are the same length? Well, we can use a circle. So the first thing we're going to do is we're going to come up with some point here. Okay, and in order to get another point that is the same distance away from F on the other side, we're going to use the compass tool. And the compass tool will allow us to say, okay, I can find a point that's exactly the same distance away from C. So point G has to be exactly the same distance away from C as F. And we can prove that because this is a circle, and every radius of the circle is the same length. That's the definition of a circle. All the points that are the same distance away from a central point. So here, this distance is the same as this one. And you'll notice that as I move F along this line, G moves also. So now I'm going to take, how did that help us, right? Well, now we can draw these two bigger circles, because if you think about it, here's our smaller circle. Then we can draw the two bigger circles to draw that line that's going to go through. So I'm going to use my radius as FG. I'm going to put one circle here, and FG is my radius again. And now you can see that these two intersecting points up here of the overlapping circles will give us 2 points that we can use to generate a line that will go directly through C and be perpendicular. And we can move F around as much as we want, and as long as we don't go on the other side, right? And it's still, that line HI is definitely going to go through C. All right, here we go. Here's an angle. So recognize that we're adding extra tools, right? Here's one diagram. We know how to make this diagram. We added more information and more ideas to create this situation, right? And now we're going to take this and add more information so that we can bisect this angle. Bisect means cut in half. We're taking this angle and we're trying to cut it in half. Here it says estimate the location of a point D so that angle ABD, I'm going to use a line segment here. Angle ABD is halfway, right? ABD is the same as DBC, right? This angle here would have to be the same as that angle there. And I'm just guessing as to where it is, okay? Literally, just guessing, okay? So I have just my judgment to say, well, this looks about equal to that. But I bet it isn't, okay? The question is, how can we make it so? How can we create that, right? Because this is the next step. Use the compass and straight edge tools to create a ray that divides CBA, angle CBA, into two congruent angles. So CBA, or ABC, right? If we want to cut that perfectly in half, we're going to create two congruent angles, this angle being the same as this angle. CBD being the same as ABD. All right? So the question is, how do we do that? Now, if we look at this, how can we use these tools to help us out? Well, this process here with the two circles splits this line segment in half. But here, we don't actually have a line segment, do we? We're trying to split this opening. Well, we might think that we could split the opening between A and C. All right, fine. So we'll try that, okay? So we'll make our two circles, right? And here, and we can use these intersecting points. And then we can put in a line. Oops. There we go. And clearly that splits this line segment. If there was a line segment between A and C, we definitely cut that line segment perfectly in half. Let me get rid of D, because D is just a distraction. Well, you guys don't have to. Let's hide this object. There we go. That sort of helps. Anyway, so let me do that. Okay, well, anyway. All right, so you can see that I've cut AC perfectly in half with this line EF. But the problem is that AC is not where it needs to be. It's off, right? Now here, in this case, we had to create two line segments that were the same distance away from the center. Well, think about this. this here is a line segment, but they're different distances away from our center, right? The center is B. The center of that angle is B, okay? So if we want to create 2 points that are the same distance away from B, well, how do we do that? I'm going to go back a few steps here. Well, up here, we use a circle with a center at C to give us 2 points that are the same distance away. All right, let's try that here. I'm going to use the compass tool. I'm going to use this as my radius, AB. And it's like, well, wait, why would I do that? Well, if I put the circle center on B, I find all the places that are exactly the same distance away as A. And here's a point right there that is exactly the same distance away. So I'm going to label that one right there. Okay? Now I have an angle here, right? ABE, that maybe I can split in half. And if you think about it, I could split this line segment AE in half, right? So let's try that. I'm going to use my compass tool, right? And I'm going to create these line segments, not line segments, 2 circles with the same radius using AE, line segment AE as the radius. And then I have these intersecting points. There's one down here, and there's one up here. And if I make a ray, I should make a ray. Actually, no, I should make a line. Let me make a line. I'll go from F up to G. And you can see that I almost made it, right? Point D is just a little bit off. It's just a little bit off from where right? A little bit off. I was just a little tiny bit off. But nevertheless, I was off, right? So I can delete that now. All right. So here you can see that this line here, GF, line GF, also goes through B, and it creates these angles which are exactly equal, right? Angle EBG and angle GBA are exactly equal, just like these 2 line segments, A, whatever point that is, which we don't have a label for, right? EH and AH are exactly the same length, just like up here, BC and AC were the same length. All right. So that was this one. It says take turns with your partner drawing and bisecting other angles. That's something you can try and do using a compass, or you can do that at GeoGebra on the blank startup page. If you just create an angle with a couple of line segments, and you're like, okay, how can I do this? Well, use the compass tool, steal this radius, put it right there, find the intersecting point. Oops. There we go, D right there. And then I can draw 2 circles using DA as my radius. And now I have these points here, this intersection point here, and this intersection point here. And if I draw a line, it will cut this angle perfectly in half. And you can also see what happens when I move point C around, right? It doesn't matter how small I make this angle, it's still going to be bisected by that line. All right? Coolio. All right, so that's that. Do the practice and get ready for the mastery check.